Next concept is a image sensing and acquisition system. In image sensing and acquisition system, so we are prepared a three principal arrangements to produce an electrical output proportional to the light intensity. In that, first one is a single sensor. First one is a single sensor, and second one is a line sensor. Second one is line sensor, and third one is a array sensor. Third one is a array sensor. So we will move into each and every sensor, how it will be workable for in this image sensor. So in this first one is, this is your first sensor, that is your single sensor. This is your second sensor, line sensor. In the first one, what is the basic principle? Okay, sensor of this type is photodiode. Now this center element is called as a sensing material, so that is your photodiode. So which is constructed of a silicon material whose output voltage waveform is proportional to the light intensity, means energy radiation which will fall onto our sensing material, so that is called a photodiode. So use this filter. So by using this filter in front of the sensor improves the selectivity of our image quality. For example, a green pass filter in front of a light sensor, so favor light in the green band of the color spectrum only. Otherwise we can prefer the red and we can prefer the blue also. Okay, so finally you are generating the output voltage. It is proportional to the corresponding radiant energy, so reflect onto your sensing material. So after finally you are getting the output voltage waveform, we can see in the analog output waveform. So now this is housing, it will be required for without any vibrating of this entire sensing equipment, so that is called as a housing equipment. So this is for a single sensor. Okay, single sensor, it will be recognize only a single pixel or double pixel of the information only, not it will be recognize the entire horizontal axis of the information or the vertical axis of the information. This reason we will move into this combination of the sensors we can prefer, so that is called as a line sensor. So that is your second one. This is our line sensor. How to connect these line sensors? How many number of sensors are connected in the line sensor in practice? We want to observe in this line sensors how many number of single sensor there, sensor 1 and sensor 2, sensor 3, sensor 4 and sensor, number of sensors are present. These all sensors are connected in series connection, means it will be scan the entire image in a horizontal axis at a time, not a vertically scanning. It is not suitable for these line sensors. But number of sensors are connected in series connection, but it will scan the image only horizontal axis or either a vertical axis. But we can both horizontal and vertical axis scanning, so we can prefer into the sensor, so that is called as a array sensor. And third one, this bottom one is our array sensor. Now third one is our array sensor. How many number of sensors are there? Okay, sensor 1, sensor 2, sensor 3, sensor 4 and 5, 6, 7 and 8. This is the matrix form, so we can observe in this case. And 20, sensor 21, sensor 23, sensor 24 and so on, continues up to last sensor here. Okay, the number of sensors are connected in the format like an array sensor, so that is in the form of like a matrix. So it will be scans the image in vertical axis as well as a horizontal axis. This reason we can prefer the array sensor. Okay, next one, image acquisition using a single sensor. How it is possible for image acquisition using a single sensor? By to reconstruct the image in the front panel of the digital computer. Or in this we have to generate a two-dimensional image using a single sensor. A two-dimensional image means whether vertical axis as well as the horizontal axis, and x and y. These are the two-dimensional image. Now here, to relative displacement in both an x y direction between the sensor and the area to be imaged, an arrangement used in the high precision scanning, where the film negative is mounted onto a drum whose mechanical rotation is provided. Now this is our film, so which is rotated by using our stepper motor, so whether anti-clockwise direction or clockwise direction. Our sensor is placed in the center position of this linear motion mandrel. So one image line out per increment of a rotation and full linear displacement of the sensor from left to right. Now in this section, now this sensor, it will move in this direction as well as left side to right side and as well as right side to left side. And now this only scans the entire image, only the horizontal axis, not a vertical axis. We can prefer the number of sensors, it will be scan the image, okay, horizontal, either vertical axis, so both the directions. Now the single sensor is mounted on the lead screw that providing the motion in the perpendicular direction. Image is the combination of a light illuminant source and a reflectant or absorption of the energy from that source by element of the sense being imaged. So then in any kind of image, two-dimensional image, we have to be written, so that is called as f of x comma y is equivalent to, so that is r of x comma y multiply with this another one, so that is I into x comma y. This is I into x comma y, whereas r of x comma y is our reflectance and I x comma y is our illumination of the light source. So we can format our digital image, so that is two-dimensional digital image by using. Now next one is the image acquisition, so using an array sensor. So what is the using of this image acquisition of a single, like using an array sensor? So from this array sensor, so we have to design this image acquisition using a sensor array. Here the electromagnetic and ultrasonic sensing devices arranged in the array format. Sensor CCD array, so that is 4000 into 4000 element or more. Response of each sensor is proportional to integral of the light energy projected onto the surface sensor. So that is a integration of the input light reduces the noise. So in a two-dimensional, if for example in practically, so this is our light source. So this light source which can be illuminated onto our sense element. So which image I want to project onto our digital computer. So that is our scenery or any kind of ball or pen. So that is our sensing element. So light can be illuminated onto the sensing element. So which can be reflect onto this reflectance of the light, so that is r of x comma y onto this imaging system. Okay, now here the imaging system, so we have to be arranging the number of filters, okay, number of morphological techniques, so number of analog to digital conversion process we have to providing this image sensing system. So your output will be available in the front panel of our analog to digital converter, our so integral, so that is your image plane. So these all are the number of image projections. Now these all are the number of image projections. Our reconstructed image, so it will be shown in the front panel of our computer in practically. Now this is our reconstructed image, but it is not a original. It has some noise and a blur and corrupted image, so which can be digitized and sampling. So by using our digitizing technique and sampling technique, so we have our reconstructed image, it will be visible in the front panel of the CPU like this. Okay, this is our output digitizing image output signal. And this is our basic concept of image acquisition and sensing.